Hi everyone, I'm Gong Tang, and right now I'm going to address my project progress report to all of you. And my project progress report contains four part. And the first part will be, I will tell you, will be the transform of the real problem into the optimization problem. And the second part is the way to solve that problem, include the model and the algorithm I will use. And the third part is the work I will finish. And the fourth part is the work I will do in the future. And my problem is a container packaging problem in 2D dimension, which means I need to put all of the box into a container and how to optimize it. And the first part of my report is to transform the real problem into the optimization problem, which means I need to have a problem with real number. So I consider a problem as follow, which I have a container with width 5 and length 10, and I set up 17 box from 1 to 17 with each width and length, and my goal is to put all of the boxes into the container, and with the least number of container I used. And here is some notation I will use in my model. W represent for the width of the container, and L represent for the length of the container. WR represent for the width of X box, and LR represent for length of I box. And yeah, here is my model. The first I will need to build a Cartesian coordinate, and then I need to build a container rectangle in this Cartesian coordinate with its length and width, L and W. So the 0, 0 will be the left down point of this rectangle, and LW will be the right top point of this container, and N represents container I used. And then I need to build a vector Tg, which dimension is I by 1, and represent whether the box I is in the container G. If box I is in the container G, Tgi will be 1, otherwise it will be 0. And here is my model. I have to get a minimum M, and the constraint as followed, which means the sum of Tg plus Wi plus which means the sum of Tg multiplied by Wi and multiplied by Li must be less than 50, which means that I could not put extra area into my container. And the second constraint, which means I could only put one box into one container. I could not put one box into more than one container. And here is other constraint which hard to represent, which like I have to make which means I could not extend the length of width of each container, and I will address it in my algorithm. Yeah, and here is the algorithm I will use. I will use two algorithms. First, I will use a greedy algorithm to solve a basic solution, and assert some articles and got a result, the heuristic packing algorithm. And the basic idea of this algorithm is here, which means I have a container, and then the first part is to put a box into the left down side of this container, and here is the box, and then the container area will decide to two parts, S1 and S2. And then when I want to put another box, first I will consider it to put into the area S1. If not, I will put it into the area S2. If still not, I will put it into the next container. And this is the basic idea of this algorithm. And I could use this algorithm to get a quick and basic solution. And then, when I got the basic solution, I will use the simulated annealing algorithm to optimize this result and to get a better result. And here is the work I have finished. I have solved the problem with heuristic packing algorithm with MATLAB. Here's my plot. This is for content. I will use a full container to put all of my 17 boxes into it. And here's container 1. I will put box 1, box 5, box 12, box 13, box 17 into it. And here is container 2, container 3, and container 4. And this is the work I have finished. And the fourth part, the work I will do in the future, and I will finish the simulated annealing algorithm. And right now I have a basic idea of it. I could exchange two positions of the box and to see whether the n is increase or decrease. And this is what I thought about this algorithm. And it may be not apparent for the problem I have. I mean the problem at site. So I maybe have a different data. I may use different data to build a different problem, which means I will use more box with a small size, and to see how this algorithm going. And here is my progress report. Thank you guys.